Hi, welcome to IM2. This is chapter 4, section 1, simplifying radical expressions. Before we begin to simplify radical expressions, we're going to take a look at properties of square roots first. So let's get started. Before I even explain this, consider this on the side. If I have a number 4, so let's take a look at 4, and I am finding the square root of 4, we know that the answer is just 2. And yes, some of you are thinking it's plus or minus 2. That's correct. However, I want you to know that in this section, when we're finding the square root of a number, we're just going to focus on the principal value of that expression, which is positive. And then consider, let's see, 9. How about 9? We know that the square root of 9 is equal to just 3. Maybe one more, we can do 25. The square root of 25 is equal to 5. And then we can keep on going, 36, 49, 64, so on and so forth. The unique thing about these numbers is that they do have there exists an integer that is a root of these numbers. And because they have a positive integer that we can find as a square root of one of these numbers are called perfect square numbers. And so as you think about 36, 49, so on and so forth, well, those are examples of perfect square numbers. What happens if I ask you to find me or to evaluate the square root of 50? You're probably going to run into some problems. And some of you are thinking, well, it's going to be a decimal. That's correct. It will be a decimal. However, in this section, we're going to avoid simplifying those expressions into a decimal. This is what we're going to need to do. I'm going to write it over here. To evaluate the square root of 50, because 50 is not a perfect square number, we're going to need to break it down into two factors. But these are special factors. One of the factors has to be a perfect square number. So we kind of have to think about some of the factors to see which one would be or might be a perfect square number. In this case, we can actually split up 50 into 25 and 2, because 25 times 2 is still 50. And right here, the product property of square roots allows us to split this up into individual square roots, where we're now writing it as 25, square root of 25 times square root of 2. Once you get over here, you understand that you're just evaluating individual square roots. We can't do anything to 2, but we can evaluate that. Well, what's the square root of 25? We already talked about it here. It's just 5. And the square root of 2, we don't know that. It's going to be a decimal for sure on the irrational number, so we're going to leave our final answer like that, simplified. Okay? And that's what this product property of square roots is all about. Let's take a look at another example. So this will be example 1. How about example 2? Find the square root of 108. Give it a try. Well, you will notice that when you're looking at 108, it's actually not a perfect square number. And we're going to need to break it apart into factors, one of which has to be a perfect square number. So in this case, after you play around with it, you're going to find out that, well, we can find factors of 108 to be 36 and 3. And then we can use the product property of square roots to split this up. I'm going to write over here. So now we have 36 times 3. We can find the square root of 36 because it's a perfect square number, which is just 6, the principal value, and then it will leave 3 ways up. Okay. All right. I'm going to move on now and go to the next section. And the next section talks about the quotient property. It is just similar to the product property, except this time we're dividing. And so anytime we're dividing, we can again split them up into individual square roots at the top and then simplify what we have to simplify. I'll actually just start with an example here. And an example for the first one is going to be the square root of 15 over the square root of 64. Well, we can split this up into individual square roots. Well, we have 64. We really can't find the square root of 15, and we can think of factors, one of which has to be a perfect square for 15, but we can find the square root of 64. So this is going to stay 15, and this is just going to stay 8. And we